This is Audio-Visual Lecture 7, Part 2. So we're working our way through a sample loading problem for a 1981 Cessna 172. We've determined the basic empty weight, which is usually a separate document that's kept with the airplane, and we'll also give you the moment. That is not changeable. That is what it is. But what we can change and calculate each time are the various fuel and passengers and baggage problems. So when you look at the Cessna chart for this, they will actually show you the different stations in the airplane to give you the arm. So when we look at this right here, I don't know if you can actually see the numbers on here, but it shows the pilot and passenger seats as being 37 inches, between 34 and 46. So they just average it out at 37 because you have to take in account the distance from the front of the seat to the back of the seat and so forth. But we're splitting the difference and getting a nice average because you could split hairs so finely that you have to recalculate it if somebody leans forward or takes a drink of water or something. So they're giving us a nice round number just to deal with. And remember that center of gravity and weight and balance has to do with the longitudinal axis. So this doesn't affect left to right. So somebody sitting in the left seat versus the right seat, it's the same arm station in the airplane. So you have 37 for the front, 73 for the back, 95 for baggage area 1, and 123 for baggage area 2. Notice how the numbers get much larger the further aft that you go. Remember, this is like the teeter-totter, and here's the middle part of the teeter-totter. So if you sit here, you have much less leverage than you do when you sit back here. So that's why more importance is given to the weight the further back that you go. If you put a 200-pound person here, they're going to have much less impact on the airplane's performance than if you stick them back here. So that's the stations that they're using, and that's where they're getting that number. So to determine the moment, which is what we're after, they're taking that weight, 37 for instance, and multiplying it by the weight that you're putting in that seat. So for instance, we're going to put 340 pounds of people in the pilot and co-pilot seat. So the combined weights of the pilot and co-pilot are 340 pounds. So 340 multiplied by 37, which is that arm, is going to give us about 12,600. That's a big number, so again we're going to divide it by 1,000, and that gives us 12.6. We've just moved the decimal place over 3 spots, which gives us a more workable number. The fuel, we're calculating the same way, but one thing that Cessna does with these charts is they'll give you another chart called a loading graph. And again, I don't know if you can see this. You'll see it much better on the quiz, I promise. You find the weight over here, and these lines right here represent the arm. So the pilot and front passenger, what we did before, we happen to know that 37 is the arm station in the airplane, so we know what to multiply the weight by. Or we can just come up to 340 on this graph and come over to the line that says pilot and front passenger and come down, and that gives us that same 12.6, which all the math is done for us. They've multiplied the arm by the weight, divided it by 1,000 pounds, and we get that same number right here. So, lucky for you, we have this chart. Now, we're going to probably do it longhand just to do it on at least the quiz or maybe the final exam, we'll see, just so that you get the concept. But that's how they're deriving this chart, is by doing all the math for you and putting it on a graph. So we have the pilot and front passenger weight right on there, and as we determine the arm is 12.6. We're going to put 40 pounds of fuel in the airplane, and again, just using this chart is going to make it go a little faster for us. Gives us 11.5. We're going to have a couple people in the back. We're going to put 340 pounds of people in the back, but instead of 12.6, this is going to give us 24.8 for a moment. And remember, it's the same weight, but they're sitting further back in the airplane, so that gives them much more influence over what is happening to the center of balance of the airplane. We're going to put 20 pounds of baggage in the back. This is going to give us a total weight for the airplane, or a taxi weight, if you will, and a total moment. And what we're going to do is add all those together. Like we said, that'll give us a taxi weight and a taxi moment. And to be very precise, so here we go. Here's our 340 pounds in the back, much greater arm moment right here because they have greater, they're sitting further in the back, so more leverage on the teeter-totter. 20 pounds of bags, 1.9, nothing in the very back, so nothing there. Gives us a total weight, a taxi weight, when we start up the engine and start moving, we've got 2,407 pounds and 108.1 for a moment. We calculate roughly, we're going to burn a gallon of gas. 1 gallon of avgas, by the way, is 6 pounds, so a little bit more than a gallon. So minus 7 pounds, therefore minus 0.3 of the moment, gives us a takeoff weight of 2,400 pounds and 107.8 on the moment. Now, what do we need to know with those numbers? Remember those two numbers for a minute. Write them down, 2,400 and 107.8. And we're going to go to our third chart here, which is the center of gravity moment envelope. We have a utility category and a normal category. Utility generally just means nothing, absolutely nothing behind the two front seats. So no baggage, no rear passengers. The normal category is for, the wife and kids and the dog. So you're not going to do any, stalls or spins or something like that. So we're going to find our weight over here. Here's 2,400 pounds. And then we're going to come over until we find the moment down here. So 107.8 is going to be somewhere right around in here. And we're coming up. And where that meets the 2,400 line, that's where we are. So we're at the very top of the envelope. The top part is weight. The left and right is balance. So we're within weight and we are within balance. We can't put a single pound more on the airplane, but we are within weight and balance. The airplane is not overweight and it's not out of balance based on that chart. So we're going to do another one, and just to give it a little more realism, we're going to give it a scenario. So let's suppose that we flew somewhere, and we flew for about an hour. We burned about 10 gallons of gas. And we got where we're going, and you've got 2 people up front, 2 people in the back, 20 pounds of bags. Let's say that you were taking, the co-pilot. Let's say you were taking the co-pilot back to school, back to college or something, and you land, and that person gets out. All right, so one person's weight has left the airplane. 1 hour's worth of fuel has left the airplane. So your weight has generally decreased, but your balance has also decreased because someone got out of the airplane. They were contributing to the teeter-totter movement. And just to make it a little more interesting, we're going to say that somebody from the back seat gets up in the front seat. So let's suppose that when we were flying initially, we had the pilot at 135, the co-pilot at 205, the person in the back at 160, and another person in the back at 180. So we get to where we're going. It's like a crime scene analysis. We get to where we're going. The co-pilot gets out, and the person who weighs 160 pounds moves up to the front seat. The person who left took their 20 pounds of bags, and we flew for an hour, and we burned 10 gallons of gasoline. So we burned 60 pounds worth of fuel. This one's not going to be too hard. All we've got to do is recompute. So here's the easy part. The weight and the moment for the basic empty weight of the airplane is the same. We've still got 1467 and 57.3. Hopefully you wrote that one down earlier just so that you can kind of follow along again, but here it is again. So back over here. So our weight is still 1467 and our moment is still 57.3. That's the easy part. Now we burned 60 pounds of fuel, so now we're down to 180. And again, just to emphasize, I'm using that chart. There are, we're going to go, we're going to find 180 on here, come over to the line that says fuel at 6 pounds per gallon, and we're going to come down on here to find our moment, and we'll determine and we'll discover when we do that our new moment for fuel is 8.5. Right? The other way that you can do that is by going to the loading arrangements that show you those stations, and you can see on here that when it says the usable fuel CG arm is located at station 48. So 180 times 48 is 8,500. Divided by 1,000, 8.5. So that's how we're getting. That's how we're getting it the long way. The short way is to just use the chart. But be comfortable with both ways because we'll probably end up doing them both ways for the exam and the quiz. So again, we're taking the weight, we're multiplying it by the arm, and that's giving us a moment, which we're dividing by 1,000 pounds just to make it easy. So 180 pounds of fuel, 8.5 is the moment. Now, for our front passengers, so that took care of the fuel. That took care of one variable. Now, the pilot is going to be the same, and the co-pilot left. So 205 pounds left the airplane, and we're going to replace that person with 160 pounds. So our new total weight for the front seat is 295 pounds, and we've got 37, right, for the station. 37 is the arm, so the front seats are 37 inches, more or less, from the center of gravity of the airplane. So 37 times 295 divided by 1,000 is going to give us 10.5. And we're just going to do this repetitively. I think it's going to be the best way to do it. The other way to do it with the chart is to go up to 295, so just shy of 300, pilot and front passengers line, come down, and that gives you 10.5. The other way to do it is with the first chart is to see the station in inches for the pilot, passenger, and those front seats. Take that number 37, multiply it by the weight, divide it by 1,000. That also gives you 10.5. So now, the only person left in the back seat weighs 180 pounds, and that's all they weigh, and there's nobody else back there. So our new weight for the back seat is 180, and either way you do it, that's going to give us 13.0 for a moment. So that person by themselves has more leverage than the two front people combined because they're sitting further from the center of gravity. They're sitting further back on the teeter-totter, if you will. The college guy took his bags, so we've got 0 for baggage weight and 0 for moment in baggage area 1. Same for baggage area 2. Now we're going to do some quick math and total up our weights. The taxi weight of the airplane is just over 2,100 pounds, and our moment's 89.3. We're going to take a gallon of gas off for taxi. That's going to take 7 pounds off of our weight and 0.3 off of our moment, and that gives us our takeoff weight of 2,115 pounds and 89 for our moment. All right, so we've totaled up our weights, totaled up our moment, gotten a takeoff weight and a takeoff moment. We're going to come over here to our chart, to our envelope. We're going to find 2,100 here and 89 over here. It's well within the normal category. It's well within the center of gravity envelope. We're good to go, and we're all within limits.